Alright, now let's take a look at what's in common with one more function here, another flat recursion function. Our third one, no, second, add one list. Alright, so let's define this. Just adds 1 to every item in the list. Alright, let's define the add one function. 1 lambda a plus 1a. Alright. Define add one list. Alright, instead of writing all this out, since we know there's going to be a lot in common, let's just paste it. Alright, now according to our little theory here, we're going to have to change that and this. So if null ls, then we're going to well, we're making a new list here, so we're going to put this as an empty list, and then instead of multiplying the car of ls into the helper of the cutter of ls, we're going to cons the well, we have to cons and we have to add 1. Alright, so let's run that, make sure it works. Add one list 1, 2, 3, 4. Alright, that works. So this is tricky though now, you see it's not let's see, hide interactions. Okay, so so we've got to be able to do this, do multiple things, cons and add 1 there for the car of ls. So what do we let's see. Alright, so let's define our flat procedure thing now. Alright, flat recur. Define flat recur lambda. This argument here, when it's the base case, we're going to call that the seed. So seed, then this multiplication on the car of ls, or the consing the add 1 of the car of ls, we're going to call that a flat procedure. Alright, now let's just mostly just define, going to return this mostly. Oh dear. Okay, so well, that's funny looking now. Okay, so here instead of that we're going to return the seed, and instead of these things, looks like you're going to have to just combine those. Flat-proc the car of ls into the cutter of ls. So flat-proc has to be a procedure which takes 2 arguments, because the one argument will be the car of ls and the second one will be the cutter of ls. Alright, then it returns that new function. Okay, now let's try it out. On let's try it out on sum. So remember, sum did like 1, 2, 3, 4. Let's redefine sum as flat recur. Remember, what is the seed? When it gets down to nothing, we're adding these together, so the seed is 0. 1 plus 2 plus 3 plus 4 plus 0. And then plus is obviously the function that we want. Alright, then let's try this sum thing again. And it gives the same result. Okay, let's do product. define product flat recur. Now what was the seed for the product? We're having a list, we want to multiply them all together, so we know that the function, the flat procedure, is going to be a multiplication, but this, so that's 1 times 2 times 3 times 4, and then we want to times it by 1 because that won't change it at all. Alright, so product 1 2 3 should be 6. Good. Of course that's the same if you do sum or product, so we're going to do 1 2 3 4. 24. That's nice because 6 times 4 is 24. Alright, well that's good, but let's see if we can do something that we haven't done quite yet already. So let's say we want a function named powers that does like takes a list, flat list of course. Oops, powers, not power. And it will raise 2 to the 3 to the whatever's next. Okay, so this should be 2 to 3, which should be 8. Of course, it won't be anything quite yet. Alright, so let's define that one. Define powers flat recur 1 exponent. Oh, I did it again. Oops. Alright. So now let's try that one. Yeah, we got 8. Alright, let's try this. 2, 3, 4. This is going to give us a really big number. Alright, let's just try powers 2, 2, 1. And what's that going to give us? Oh, not again. 2, 2, 1, 4. Alright, good. Now let's do these are all a little bit easier. Right, because that's just one function that you've got to pass in. So what about this one up here for add one list? See, we have to do 2 things here. So that's going to be a bit harder. So define add one list. Oops. Flat recur, and we'll give it oh, the seed is the empty list, as you can see there, and then the flat procedure is this combination of cons and add one. So it's basically we're going to have to combine those together. Takes 2 arguments, the cart of ls and the helper, and going to have the cons the add one of A, which is the car, onto B. Alright, let's try this now. Add one list, 2, 3, 4, and it works. Alright, so this is starting to get complicated enough that it's almost just easier to program it in yourself. But the idea of abstraction is that you can do very complicated things then using your little. So this is a particularly simple example doing flat recursion, but there may be something that's very complicated that you can abstract like this and just generate these very complicated functions on the fly, just by providing, you know, like a seed and some other procedures or something, and it will make your life much simpler. So this abstraction concept is the important part for you to come away with. It's not necessarily good for you to be abstracting flat recursion though. Alright, now that's it for this subject.